Here's something fascinating. ChatGPT can analyze complex situations in seconds without getting emotional or biased. DeepMind makes perfect strategic decisions every time. Meanwhile, your brain processes over 20,000 decisions daily. And most of them are wrong because of cognitive biases you don't even know you have. Today, I'm going to show you exactly how artificial intelligence thinks, and how you can use the same mental frameworks to make better decisions, solve problems faster, and think more clearly than you ever thought possible. Chapter 1. AI versus Human Psychology Fundamentals. Let me tell you about Sarah. She's a marketing director who thought she was brilliant at reading people, until she hired 3 terrible employees in a row, completely missed the red flags in her relationship, and kept making the same financial mistakes over and over again. The problem wasn't her intelligence. Sarah has an MBA from Northwestern and consistently outperformed her peers. The problem was, she was thinking like a human instead of thinking like AI. Here's what most people don't realize. Your brain is fundamentally designed for survival, not success. Every decision you make gets filtered through ancient programming that helped your ancestors avoid getting eaten by lions, but absolutely destroys your ability to make good choices in the modern world. Think about it this way. When you walk into a job interview, your brain immediately starts scanning for threats. Is this person going to reject me? Do they seem hostile? What if I say something stupid? Meanwhile, an AI system would be analyzing speech patterns, facial microexpressions, body language, word choice, and dozens of other variables to determine the optimal response strategy. No emotion, no fear. Just pure data processing leading to the best possible outcome. This is where the fundamental difference lies, and it's costing you opportunities every single day. Humans use what psychologists call heuristics, which are basically mental shortcuts. These shortcuts work great when you need to decide whether that rustling bush might contain a predator. But they fail miserably when you're trying to evaluate a business opportunity, choose the right partner, or make strategic career decisions. AI systems don't use shortcuts. They use what I call systematic processing. Instead of jumping to conclusions based on limited information, they analyze all available data points simultaneously, instead of being influenced by their mood, recent experiences, or social pressure. They evaluate each situation based purely on logical probability and expected outcomes. The clear framework helps you understand exactly how to bridge this gap. The letter C stands for comprehensive data gathering versus selective attention. The letter L represents logical processing versus emotional reaction. The letter E means evidence-based conclusions versus assumption-based decisions. The letter A signifies algorithmic thinking versus random intuition. The letter R represents rational optimization versus biased selection. Let's break this down with real examples you can use immediately. Comprehensive data gathering means you stop making decisions based on the first few pieces of information you receive. The mistake of Sarah when hiring was that she fell in love with candidates who interviewed well, without systematically evaluating their track record, references, work samples, and behavioral indicators. An AI system would weight all these factors equally, rather than being swayed by charisma or first impressions. When Netflix recommends a movie, it doesn't just look at what you watched last week. It analyzes your viewing history, the time of day you watch certain genres, how long you spend browsing, what you start but don't finish, ratings you've given, and patterns from millions of other users with similar preferences. That's comprehensive data gathering. Most humans make decisions based on whatever happens to be most memorable or recent. Logical processing means removing emotional interference from your decision-making process. This doesn't mean becoming emotionless. It means recognizing when emotions help you and when they hurt you. Fear can save your life when you're crossing a busy street, but it will destroy your career if it stops you from taking calculated risks or speaking up in meetings. Evidence-based conclusions means you stop generalizing from limited personal experience. Sarah avoided hiring anyone under 25 because she had one bad experience with a young employee 3 years ago. Meanwhile, data shows that age has almost no correlation with job performance in most roles. An AI system would recognize that sample size of one experience is statistically meaningless. This happens constantly in dating, investing, and business decisions. Someone loses money on one stock and decides the entire market is rigged. Someone has a bad experience with a particular type of person and writes off everyone in that category. AI systems don't form emotional attachments to past experiences. They update their models based on new information without being anchored to historical outliers. Algorithmic thinking means following systematic processes rather than random intuition. When you're solving a complex problem, instead of hoping for inspiration or going with your gut feeling, you break it down into component parts. Identify the key variables, test different approaches systematically, and optimize based on results. Rational optimization means you choose options based on expected outcomes rather than what feels comfortable or familiar. Humans have a strong bias toward maintaining the status quo even when change would clearly benefit them. AI systems evaluate every option based purely on which one maximizes the desired outcome. Sarah stayed in her job for 2 years longer than she should have because leaving felt risky and uncertain. An AI analysis would have shown that staying was actually the riskier choice. Given the declining market position of the company and her limited growth opportunities, the fear of uncertainty prevented her from making the rational choice. Here's what happens when you start implementing AI thinking patterns. First, your decision quality improves dramatically because you're working with better information and clearer logic. Second, you become much less susceptible to manipulation, whether from salespeople, politicians, or toxic relationships, because you're evaluating claims based on evidence rather than emotional appeal. Third, you start identifying opportunities that other people miss entirely. While everyone else is reacting emotionally to market changes, economic news, or social trends, you're analyzing the underlying patterns and positioning yourself strategically. This is how smart money makes profit during economic uncertainty, while everyone else panics and makes terrible decisions. Here's your first practical exercise to start rewiring your brain immediately. For the next week, before making any significant decision, ask yourself these 3 AI-inspired questions. First, what data am I missing that could change my conclusion? Most people make decisions with incomplete information because gathering more data feels like work. AI systems automatically seek out missing variables before processing. Second, what assumptions am I making based on past experience rather than current evidence? Sarah assumed young employees were unreliable based on one experience 3 years ago. What outdated beliefs are you carrying that no longer serve you? Challenge every assumption by asking whether you have enough recent, relevant data to support it. Third, if I removed all emotional attachment from this decision, what would pure logic suggest? This doesn't mean ignoring emotions completely, but rather understanding what your logical brain recommends before factoring in emotional considerations. Often, you'll find that your emotional preferences align with logical analysis anyway. But sometimes you'll discover that fear or comfort seeking is leading you towards suboptimal choices. Start applying this with small decisions first. Which restaurant to choose? What route to take home? Which project to prioritize at work? As you get comfortable with systematic thinking on minor choices, you'll naturally begin applying it to bigger decisions like career moves, relationships, and investments. The goal isn't to become emotionless or lose your humanity. It's to develop the cognitive flexibility to choose your thinking style based on what the situation requires. Sometimes intuitive, emotional thinking serves you better. Sometimes systematic, logical analysis produces superior results. AI psychology gives you the tools to consciously choose your cognitive approach rather than defaulting to whatever thinking pattern feels most comfortable. Watch what happens to your results when you start thinking like artificial intelligence, while maintaining your human creativity and emotional intelligence. The combination is absolutely unstoppable. Chapter 2. Machine Learning Mental Models. Here's something that will blow your mind. Machine learning systems get better at everything they do, every single time they do it. Meanwhile, most humans repeat the same mistakes for years without improving. They go to the same type of toxic relationships, make the same financial errors, and fall into the same career traps over and over again. But what if you could learn like a machine learning algorithm? What if every mistake actually made you exponentially better instead of just frustrated? Let me introduce you to Marcus, a software engineer who was stuck in his career for 5 years. Despite being technically competent, he kept getting passed over for promotions, struggled with imposter syndrome, and felt like he was spinning his wheels. Then he discovered how machine learning algorithms actually work, and everything changed. Within 18 months, he got promoted twice, started a successful side business, and became the go-to problem solver on his team. The difference wasn't that Marcus became smarter. The difference was that he started learning like an AI system instead of learning like a typical human. Here's what most people don't understand about learning. Humans tend to learn in what I call single-loop learning. You try something, it works or doesn't work, and you move on. Machine learning uses double-loop learning, where every experience gets analyzed for patterns, optimized for better results, and integrated into a continuously improving system. Think about how you learn to drive. You've probably made mistakes, got corrected, and eventually developed enough muscle memory to drive safely. But you probably haven't gotten dramatically better at driving since you passed your test, right? That's single-loop learning. A self-driving car, on the other hand, gets better every single mile it drives, analyzing weather conditions, traffic patterns, road surfaces, and thousands of other variables to optimize performance continuously. The Learn framework shows you exactly how to implement machine learning mental models in your daily life. The letter L stands for log every experience systematically. The letter E means extract patterns from your data. The letter A represents adjust your approach based on findings. The letter R signifies repeat with optimized strategies. The letter N represents never stop iterating and improving. Let's start with logging every experience systematically. This sounds tedious, but it's actually what separates high performers from everyone else. Marcus started keeping what he called a decision journal. Every significant choice he made, he wrote down his reasoning, his expected outcome, and what actually happened. Most people skip this step because it feels like extra work, but this data becomes incredibly valuable over time. Here's a practical example. You're dating and keep ending up with people who seem great initially, but turn out to be wrong for you. Instead of just feeling frustrated and trying again with someone new, you start logging the data. What attracted you to each person? What red flags did you ignore? What patterns emerge when you look at your last 5 relationships? Marcus discovered that he was consistently attracted to high-energy, charismatic people who turned out to be unreliable and self-centered. This wasn't obvious in individual cases, but the pattern became clear when he analyzed the data systematically. Once he recognized this pattern, he could consciously choose to value consistency and kindness over excitement and charm. Extracting patterns from your data is where the real magic happens. Machine learning algorithms don't just collect information, they identify relationships and correlations that humans typically miss. You start noticing that you make better decisions when you're well rested, that certain types of people drain your energy, that you're more creative at specific times of day, or that you perform better when you prepare in certain ways. This isn't just about relationships and career decisions. Marcus applied pattern recognition to everything. He tracked his mood, energy levels, productivity, and decision quality across different variables like sleep, exercise, diet, and work environment. He discovered that he was 30% more productive when he worked from coffee shops rather than his home office, and that he made better strategic decisions after morning workouts rather than afternoon ones. Adjusting your approach based on findings means you actually change your behavior instead of just collecting interesting data. This is where most people fail. They recognize patterns but don't systematically modify their approach. Marcus didn't just realize that coffee shops made him more productive. He restructured his entire work schedule around this insight. The key is making incremental improvements rather than dramatic overhauls. Machine learning algorithms improve through thousands of tiny adjustments, not massive changes. If you discover that you make poor financial decisions when you're stressed, you don't necessarily need to eliminate all stress from your life. You can create a simple rule that you wait 24 hours before any significant financial decision when your stress level is high. Repeating with optimized strategies means you systematically test your improvements to see if they actually work. Marcus didn't just assume that his new approaches were better, he measured the results. When he started prioritizing consistency over excitement in dating, did his relationship satisfaction actually improve? When he changed his work environment, did his productivity metrics actually increase? This requires what machine learning engineers call A/B testing in your personal life. You try your new approach for a defined period, measure the results against your previous baseline, and then decide whether to keep the change or try something different. Most people change multiple variables at once and then can't figure out what's actually making the difference. Never stop iterating and improving means you view your entire life as a continuous optimization project. Machine learning systems never reach a point where they stop learning and improving. They're always processing new data, identifying new patterns, and updating their models. You can develop this same mindset about your personal and professional development. Marcus realized that he had been thinking about skills and habits as fixed entities. You either know how to negotiate or you don't. You're either organized or you're not. You're either good with people or you're not. Machine learning thinking recognizes that every capability can be continuously improved through systematic practice and optimization. Here's where it gets really powerful. Most people have random, inconsistent results because they don't systematically learn from their experiences. They succeed sometimes and fail sometimes, but they don't extract the underlying principles that create success. When you start learning like a machine learning algorithm, your results become more consistent and predictable because you're continuously optimizing based on data rather than hoping for luck. The compound effect of this approach is extraordinary. Small improvements compounded over time create massive differences in outcomes. Marcus didn't transform overnight, but his systematic approach to learning and optimization meant that he was consistently getting better at everything he cared about. While his colleagues were having the same problems year after year, he was solving them permanently and moving on to bigger challenges. Think about the areas of your life where you keep having the same problems or getting similar results. Relationship patterns, financial habits, career challenges, health issues, productivity problems. What if instead of just hoping things would get better, you applied machine learning principles to systematically identify what's working, what's not working, and how to optimize for better outcomes? Here's your implementation strategy for this week. Choose one area of your life where you want better results. Start logging your decisions, actions, and outcomes in that area. Don't try to change anything yet, just collect data. After 1 week, analyze the patterns. What approaches consistently produce better outcomes? What factors seem to predict success or failure? Then make one small optimization based on your findings and test it for another week. Continue this process of data collection, pattern recognition, and systematic improvement. Within a month, you'll start seeing measurable improvements. Within 6 months, you'll have transformed that area of your life completely. The most successful people in every field are unconscious competent at this process. They naturally extract lessons from every experience, continuously optimize their approaches, and get better results over time. Now you can make this process conscious and systematic, accelerating your improvement in every area that matters to you. Remember, machine learning isn't just about technology. It's about having a growth mindset backed by systematic data collection and optimization. When you start viewing every experience as data that can improve your future performance, you develop what I call exponential learning capabilities. Instead of repeating the same year of experience 20 times, you're actually accumulating 20 years of optimized learning. This is what separates people who plateau in their careers, relationships, and personal development from those who continue growing and achieving at higher levels throughout their lives. The difference isn't talent or luck, it's having systematic approaches to learning and improvement that compound over time. Chapter 3. Data-Driven Decision Psychology. Here's something that will change how you make every decision for the rest of your life. Most people make choices based on emotions, recent experiences, or what feels right in the moment. Meanwhile, the most successful individuals in every field make decisions like AI systems, using data and systematic analysis to predict outcomes and optimize results. The difference in life outcomes between these two approaches is absolutely staggering. Meet Jennifer, a real estate agent who was struggling despite working harder than anyone else in her office. She was putting in 60-hour weeks, following up with every lead, and genuinely caring about her clients. But her income was stuck at average levels, while some of her colleagues were making 3 times as much working fewer hours. The problem wasn't her work ethic or her skills. The problem was her decision-making process. Jennifer was making emotional decisions instead of data-driven decisions. She was choosing clients based on who seemed nicest, focusing on properties she personally found appealing, and spending time on activities that felt productive rather than activities that actually generated results. When she learned to make decisions like an AI system, everything changed. Her income doubled within 8 months, and she started working fewer hours while achieving better outcomes. Here's what most people don't realize about decision-making. Every choice you make is essentially a prediction about the future. You're betting that this action will produce better results than alternative actions. The problem is that humans are terrible at prediction because we use emotional reasoning, small sample sizes, and cognitive biases instead of systematic data analysis. AI systems excel at prediction because they use vast amounts of data, recognize complex patterns, and remain objective about outcomes. They don't get attached to particular strategies or let past successes cloud their judgment about current opportunities. They evaluate every decision based purely on expected results given available evidence. The data framework shows you exactly how to implement this in your daily life. The letter D stands for define your actual objectives clearly. The letter A means analyze relevant information systematically. The letter T represents test your assumptions before committing. The letter A signifies adjust based on real-world feedback. Let's start with defining your actual objectives clearly. This sounds obvious, but most people have never explicitly defined what they're actually trying to achieve. Jennifer thought her goal was to help people find homes they'd love. That's a nice sentiment, but it's not a clear objective you can optimize for. When she redefined her goal as maximizing income per hour worked while maintaining client satisfaction above 90%, she could suddenly make much better decisions. The key insight is that you can't optimize what you haven't defined. Jennifer discovered that she was spending 30% of her time on activities that felt important but didn't actually contribute to her goals. She was organizing client events, decorating her office, and perfecting her marketing materials when she should have been focusing on lead generation and closing strategies. Analyzing relevant information systematically means you gather data before making decisions instead of going with your gut feeling or following conventional wisdom. Most people make choices based on limited information because research feels like work. AI systems automatically seek out relevant data points before processing any decision. Jennifer started tracking everything, which led sources produced the highest quality clients. What time of day generated the best response rates for calls? Which neighborhoods had the fastest sales cycles? What price ranges offered the best commission-to-effort ratios? Which marketing strategies actually generated measurable results versus just making her feel busy? The patterns that emerged were surprising. Her most profitable clients came from referrals, not online leads. Her conversion rate was 40% higher when she called prospects before 10 a.m. rather than in the afternoon. Luxury properties took longer to sell, but generated higher satisfaction scores and more referrals. Her expensive marketing materials had zero correlation with client acquisition. Testing your assumptions before committing means you run small experiments rather than betting everything on unproven strategies. This is where most people make expensive mistakes. They implement major changes based on theories or advice without testing whether those changes actually produce better results in their specific situation. Jennifer didn't immediately overhaul her entire business based on her initial data analysis. Instead, she ran controlled tests. She spent 1 month focusing primarily on referral generation and measured the results. She tested different call times with similar prospect types. She experimented with simplified marketing materials to see if they produced similar results at lower cost. Here's the crucial part about testing. You need to measure actual outcomes, not just how strategies feel. Jennifer's old approach felt more professional and comprehensive, but her new approach produced measurably better results. Most people stick with strategies that feel right rather than strategies that work right. Adjusting based on real-world feedback means you continuously optimize your approach based on actual results rather than theoretical improvements. AI systems never stop learning and adapting. They don't get emotionally attached to particular strategies or assume that what worked in the past will continue working in the future. Jennifer implemented a systematic review process. Every month, she analyzed which activities produced the best results and allocated more time to those activities. She identified which approaches weren't working and either modified them or eliminated them entirely. She treated her business like a continuously optimizing system rather than a fixed set of procedures. This iterative improvement process is incredibly powerful because small optimizations compound over time. Jennifer didn't transform overnight, but her systematic approach to decision-making meant she was consistently improving in every area that mattered, while her colleagues were repeating the same strategies year after year. She was continuously upgrading her approach based on real-world evidence. The psychological barrier most people face is that data-driven decision-making initially feels less satisfying than emotional decision-making. Following your gut feels authentic and intuitive. Analyzing data feels mechanical and cold. But here's what you discover when you start implementing this approach. Better results feel amazing. And consistently achieving your objectives builds genuine confidence. Jennifer initially missed the excitement of making spontaneous decisions and trusting her instincts. But when her income doubled and her stress decreased, she realized that systematic decision-making actually gave her more freedom, not less. Instead of hoping for good outcomes, she was engineering good outcomes through better decision processes. Here's the practical implementation for this week. Choose one area of your life where you make regular decisions. It could be financial choices, career moves, health habits, or relationship decisions. For the next week, before making any significant choice in that area, write down your specific objective, gather relevant data. Identify what assumptions you're making, and create a simple way to measure whether your decision actually produces the outcome you want. Most people discover that they've been making decisions based on outdated information, unclear objectives, or untested assumptions. Simply applying the data framework will immediately improve your decision quality and help you achieve better outcomes with less stress and uncertainty. Remember, every successful AI system is fundamentally a decision-making system that uses data to predict and optimize outcomes. When you start making decisions like an AI system, you gain the same advantages: better predictions, fewer mistakes, and continuously improving results. Chapter 4. Pattern recognition like I hear something that will fundamentally change how you see the world. Right now, you're surrounded by patterns that predict the future, reveal hidden opportunities, and explain why certain outcomes keep happening in your life. But most people can't see these patterns because human brains are designed to focus on individual events rather than underlying systems. AI excels at pattern recognition because it can simultaneously analyze thousands of variables and identify connections that humans typically miss. Let me tell you about Robert, a marketing consultant who was frustrated because his business felt completely unpredictable. Some months he'd land 3 new clients easily. Other months he'd struggle to find even one. Some marketing campaigns would exceed all expectations. Others would flop completely. He felt like success was mostly luck, and he was exhausted from constantly hustling without knowing what actually worked. Then Robert learned to recognize patterns like an AI system, and everything changed. Within 6 months, he could predict with 80% accuracy which prospects would become clients, which marketing strategies would generate the best ROI, and even which months would be most profitable. His income became predictable and scalable because he understood the underlying patterns that drive success in his industry. Here's what most people don't understand about pattern recognition. Humans naturally look for simple cause and effect relationships. But real-world success usually depends on complex interactions between multiple variables. AI systems excel at identifying these multivariable patterns that create predictable outcomes over time. The SCOPE framework teaches you to recognize patterns like AI systems. The letter S stands for systematic data collection across time periods. The letter C means correlation analysis between multiple variables. The letter O represents outcome prediction based on pattern identification. The letter P signifies pattern validation through controlled testing. The letter E represents evolution of patterns over time and changing conditions. Let's start with systematic data collection across time periods. Most people only pay attention to obvious patterns that happen frequently. But the most valuable patterns often emerge only when you analyze data over longer periods and look for subtle correlations. Robert started tracking not just his sales results, but dozens of variables that might influence those results. He tracked seasonal trends, economic indicators, his personal energy levels, Chapter 4. Pattern recognition like a sick. Here's something that will fundamentally change how you see the world. Right now, you're surrounded by patterns that predict the future, reveal hidden opportunities, and explain why certain outcomes keep happening in your life. But most people can't see these patterns because human brains are designed to focus on individual events rather than underlying systems. AI excels at pattern recognition because it can simultaneously analyze thousands of variables and identify connections that humans typically miss. Let me tell you about Robert, a marketing consultant who was frustrated because his business felt completely unpredictable. Some months he'd land 3 new clients easily. Other months he'd struggle to find even one. Some marketing campaigns would exceed all expectations. Others would flop completely. He felt like success was mostly luck, and he was exhausted from constantly hustling without knowing what actually worked. Then Robert learned to recognize patterns like an AI system, and everything changed. Within 6 months, he could predict with 80% accuracy which prospects would become clients, which marketing strategies would generate the best ROI, and even which months would be most profitable. His income became predictable and scalable because he understood the underlying patterns that drive success in his industry. Here's what most people don't understand about pattern recognition. Humans naturally look for simple cause and effect relationships. But real-world success usually depends on complex interactions between multiple variables. AI systems excel at identifying these multivariable patterns that create predictable outcomes over time. The SCOPE framework teaches you to recognize patterns like AI systems. The letter S stands for systematic data collection across time periods. The letter C means correlation analysis between multiple variables. The letter O represents outcome prediction based on pattern identification. The letter P signifies pattern validation through controlled testing. The letter E represents evolution of patterns over time and changing conditions. Let's start with systematic data collection across time periods. Most people only pay attention to obvious patterns that happen frequently. But the most valuable patterns often emerge only when you analyze data over longer periods and look for subtle correlations. Robert started tracking not just his sales results, but dozens of variables that might influence those results. He tracked seasonal trends, economic indicators, his personal energy levels, the types of content he was creating, his networking activities, referral sources, client industry patterns, project complexity, pricing strategies, and even his sleep quality and exercise habits. This sounds like a lot of work, but most of this data was easy to collect with simple tracking systems. The key insight is that valuable patterns often involve interactions between seemingly unrelated variables. Robert discovered that his best clients came from networking events, but only when he attended events in specific industries during particular months of the year. He never would have noticed this connection without systematic data collection. Correlation analysis between multiple variables means you look for relationships that aren't immediately obvious. This is where AI thinking really separates itself from typical human analysis. Most people focus on one variable at a time, but the most important patterns usually involve multiple factors working together. Robert found that his most successful marketing campaigns shared three characteristics. They were launched on Tuesdays. They included specific types of social proof, and they were promoted when his target audience was dealing with particular seasonal challenges. None of these factors alone predicted success, but the combination was incredibly reliable. This applies to every area of life. Your productivity patterns might depend on sleep quality, plus ambient temperature, plus the type of work you're doing, plus your caffeine intake, plus the time of day. Your investment returns might correlate with market volatility, plus news sentiment, plus seasonal trends, plus your emotional state when making decisions. Outcome prediction based on pattern identification is where pattern recognition becomes incredibly powerful. Once you've identified reliable patterns, you can predict future outcomes with remarkable accuracy. Robert could look at a potential client and predict with high confidence whether they would hire him based on patterns he'd identified in successful client relationships. He noticed that clients who responded to initial emails within 4 hours were 70% more likely to sign contracts. Prospects who asked detailed questions about his process rather than just pricing were 80% more likely to become long-term clients. Companies that were in growth phases rather than cost-cutting phases were 90% more likely to approve higher budgets. These patterns allowed him to focus his time and energy on the highest probability opportunities while quickly identifying prospects who were unlikely to convert. Instead of treating every lead equally, he could allocate his resources based on predictive patterns. Pattern validation through controlled testing means you verify that your patterns actually work rather than just assuming they're correct. This is crucial because humans are prone to seeing patterns that don't actually exist, especially when we want to believe certain relationships are true. Robert didn't just assume his patterns were accurate, he tested them systematically. When he identified a potential pattern, he would use it to make predictions about future outcomes and then measure whether those predictions were correct. Some patterns that seemed obvious turned out to be coincidences, while other subtle patterns proved to be incredibly reliable. For example, he initially thought that larger companies were better clients. But when he tested this assumption, he discovered that company size had no correlation with project success or payment reliability. The real predictors were decision-making speed and budget approval processes, which didn't correlate with company size. Evolution of patterns over time and changing conditions means you recognize that patterns aren't permanent. What works in one economic environment might not work in another. Consumer behavior patterns change. Technology disrupts established patterns. Systems continuously update their pattern recognition based on new data rather than assuming past patterns will continue indefinitely. Robert built systematic review processes to identify when his patterns were changing. Every quarter, he analyzed whether his predictive patterns were still accurate or whether new patterns were emerging. This allowed him to adapt quickly to changing market conditions, while his competitors were still relying on outdated assumptions. Here's where pattern recognition becomes exponentially powerful. Once you develop systematic approaches to identifying and validating patterns, you start seeing opportunities everywhere. You notice patterns in stock market behavior, real estate cycles, career advancement opportunities, relationship dynamics, health and energy optimization, and countless other areas. Most importantly, you develop what I call meta-pattern recognition. You start identifying patterns in how patterns work. You notice which types of data are most predictive, which correlation techniques work best in different situations, and how to distinguish real patterns from coincidences more effectively. The compound effect of superior pattern recognition is extraordinary. You make better predictions about future outcomes. You identify opportunities before they become obvious to everyone else. You avoid problems by recognizing warning patterns early. You optimize your strategies based on what actually works rather than what you hope will work. Here's your implementation strategy for developing a high-level pattern recognition. Choose one area of your life where you want better results and start systematically collecting data about relevant variables. Track not just outcomes, but potential contributing factors that might influence those outcomes. After collecting data for at least 2 weeks, start looking for correlations between variables and outcomes. Which combinations of factors seem to predict success? Which variables appear unrelated to results? Test your hypotheses by using your identified patterns to make predictions about future outcomes. Remember, the goal isn't to find simple explanations, but to identify the complex, multivariable patterns that actually drive results in your specific situation. This is how you develop the pattern recognition capabilities that separate high performers from everyone else. Chapter 5. Logical Framework Construction. Here's something that will transform how you approach every complex problem for the rest of your life. Most people tackle difficult situations with random trial and error, hoping they'll stumble upon solutions through persistence or luck. Meanwhile, AI systems solve complex problems by constructing logical frameworks that break down challenges into manageable components and process them systematically. The difference in results is absolutely extraordinary. Meet Angela, a project manager at a tech startup who is drowning in chaos. Every project seemed to spiral out of control despite her best efforts. Deadlines were constantly missed. Team members were confused about priorities. Stakeholders were frustrated with communication. And she was working 70-hour weeks just to keep things from completely falling apart. She was smart, hardworking, and experienced, but she felt like she was failing at everything that mattered. Then Angela learned to construct logical frameworks like AI systems, and everything changed. Within 3 months, her project success rate improved from 60% to 95%. Team satisfaction increased dramatically. Stakeholder complaints virtually disappeared. And she was working normal hours while achieving better results than ever before. The transformation wasn't magic, it was systematic thinking. Here's what most people don't understand about problem solving. Complex challenges feel overwhelming because human brains try to process everything simultaneously. We get paralyzed by the sheer number of variables, interdependencies, and potential outcomes. AI systems excel at complex problem-solving because they break challenges into logical components and process them in systematic sequences. The LOGIC framework shows you exactly how to construct systematic approaches to any complex problem. The letter L stands for List all components and variables. The letter O means organize components into logical relationships. The letter G represents generate systematic processing sequences. The letter I signifies identify decision points and criteria. The letter C represents create feedback loops and optimization mechanisms. Let's start with listing all components and variables. Most people dive into problem solving without fully understanding what they're dealing with. Angela's first breakthrough came when she realized she'd never systematically identified all the elements involved in successful project management. She just assumed she knew what was important and jumped straight into execution. When she started listing everything systematically, she discovered dozens of variables she'd been handling inconsistently or ignoring entirely. Stakeholder communication preferences, team member skill assessments, resource allocation timing, risk identification processes, quality control checkpoints, change management procedures, and dependency mapping were all crucial elements that she'd been managing randomly rather than systematically. The key insight is that you can't systematically manage what you haven't systematically identified. Angela discovered that project failures usually resulted from overlooked components rather than poor execution of known elements. Once she had comprehensive lists of all relevant variables, she could design systems to manage them effectively. Organizing components into logical relationships means understanding how different elements influence each other and creating systematic approaches to managing those interdependencies. This is where most people struggle because they treat related components as separate issues instead of recognizing the underlying connections. Angela realized that team communication, stakeholder expectations, and timeline management weren't separate problems. They were interconnected elements that needed coordinated solutions. Poor communication led to unclear expectations, which created unrealistic timelines, which generated stress and confusion, which degraded communication quality even further. By mapping these relationships systematically, she could design interventions that improved multiple areas simultaneously. Instead of trying to fix communication problems, expectation problems, and timeline problems separately, she created integrated systems that addressed all three issues through coordinated processes. Generating systematic processing sequences means creating step-by-step approaches that ensure important elements get handled in optimal order. Most people approach complex problems randomly, working on whatever feels most urgent or interesting rather than following logical sequences that maximize effectiveness. Angela developed what she called project initiation protocols. Instead of jumping into execution mode immediately, every project followed a systematic sequence: stakeholder alignment sessions, requirement specification processes, resource assessment procedures, risk identification workshops, timeline development meetings, and communication framework establishment. Only after completing these steps would actual development work begin. This systematic sequencing eliminated most of the chaos that had been plaguing her projects. Team members knew exactly what to expect and when. Stakeholders understood their roles and responsibilities clearly. Potential problems were identified and addressed before they became crisis situations. Identifying decision points and criteria means recognizing where choices need to be made and establishing clear standards for making those choices effectively. Most people make decisions reactively when they're forced to, rather than proactively identifying decision points and preparing systematic approaches for handling them. Angela mapped out all the decision points that occurred during typical projects and developed criteria for making each type of decision consistently. budget allocation decisions, timeline modification choices, resource reallocation options, scope change evaluations, and quality versus speed trade-offs. All had predetermined frameworks that eliminated guesswork and reduced decision fatigue. This is incredibly powerful because decision quality often determines project outcomes more than execution quality. When you have clear criteria for making decisions, you can respond quickly and confidently to changing circumstances rather than getting stuck in analysis, paralysis, or making emotional choices under pressure. Creating feedback loops and optimization mechanisms means building systems that continuously improve your frameworks based on real-world results. AI systems don't just execute predetermined algorithms. They continuously update their approaches based on new data and changing conditions. Angela implemented systematic review processes at multiple levels. Weekly team feedback sessions identified operational improvements. Monthly stakeholder reviews assessed communication effectiveness. Quarterly project retrospectives analyzed overall framework, performance, and identified optimization opportunities. Annual strategy reviews updated her frameworks based on industry changes and organizational evolution. This continuous improvement approach meant that her project management capabilities kept getting better over time, instead of repeating the same processes indefinitely. She was constantly upgrading her systems based on practical experience and measurable results. Here's where logical framework construction becomes exponentially powerful. Once you develop systematic approaches to building frameworks, you can apply this process to any complex challenge: career development, relationship management, health optimization, financial planning, business strategy. Personal productivity and learning new skills all become much more manageable when you approach them with logical frameworks. Most importantly, you develop what I call systematic thinking capabilities. Instead of feeling overwhelmed by complexity, you automatically break challenges into components, organize them logically, and create step-by-step approaches that make progress predictable and measurable. The psychological transformation is remarkable. Instead of feeling anxious about complex problems, you feel confident because you have systematic approaches for handling them. Instead of working harder, you work smarter by applying logical frameworks that eliminate wasted effort and maximize results. Angela went from feeling like she was constantly fighting fires to feeling like she was systematically building sustainable success. Her frameworks handled routine decisions automatically, identified potential problems before they became urgent, and created predictable processes that consistently delivered excellent results. Here's your implementation strategy for developing logical framework construction capabilities. Choose one complex area of your life that currently feels chaotic or unpredictable. Apply the logic framework systematically. List all relevant components. Organize them into logical relationships. Generate systematic processing sequences. Identify key decision points and create feedback mechanisms. Start with something manageable rather than trying to framework your entire life simultaneously. Master the process with one challenge. Then gradually apply systematic framework construction to other areas that matter to you. What you'll discover is that most complexity is artificial. When you break challenges into logical components and create systematic approaches for managing them, problems that seemed overwhelming become completely manageable. This is how you develop the systematic thinking capabilities that separate high performers from everyone else. Chapter 6. Bias Elimination Techniques. Here's something that will shock you. Every single day, your brain makes thousands of decisions based on faulty information, false assumptions, and systematic errors in thinking that you don't even realize are happening. These cognitive biases cost people millions of dollars, destroy relationships, sabotage careers, and create decades of frustration and missed opportunities. Meanwhile, AI systems make better decisions specifically because they've eliminated these human thinking errors. Let me tell you about Michael, a successful attorney who thought he was exceptionally rational and objective. He prided himself on logical thinking and evidence-based analysis. But despite his intelligence and experience, he kept making costly mistakes in business investments, hiring decisions, and even personal relationships. He'd choose business partners who seemed impressive but turned out to be unreliable. He'd hire associates who interviewed well but performed poorly. He'd make investment decisions that seemed logical but consistently underperformed. Michael assumed these failures were just bad luck or insufficient information. Then he learned about cognitive biases and realized that his brain was systematically sabotaging his decision-making in predictable ways. When he implemented AI-inspired bias elimination techniques, everything changed. His investment returns improved by 40%. His hiring success rate went from 70 to 95%, and he avoided several business partnerships that would have been disasters. Here's what most people don't understand about human thinking. Your brain wasn't designed for optimal decision-making in modern environments. It evolved for survival in primitive conditions where quick judgments about immediate threats were more important than accurate analysis of complex information. These evolutionary shortcuts create systematic errors that AI systems are specifically designed to avoid. The CLEAR framework provides systematic approaches to eliminating the most costly cognitive biases. The letter C stands for catch biases in real time through awareness. The letter L means logic check your reasoning processes. The letter E represents evidence gathering from multiple perspectives. The letter A signifies alternative scenarios and devil's hash. Chapter 6. Bias Elimination Techniques. Here's something that will shock you. Every single day, your brain makes thousands of decisions based on faulty information, false assumptions, and systematic errors in thinking that you don't even realize are happening. These cognitive biases cost people millions of dollars, destroy relationships, sabotage careers, and create decades of frustration and missed opportunities. Meanwhile, AI systems make better decisions specifically because they've eliminated these human thinking errors. Let me tell you about Michael, a successful attorney who thought he was exceptionally rational and objective. He prided himself on logical thinking and evidence-based analysis. But despite his intelligence and experience, he kept making costly mistakes in business investments, hiring decisions, and even personal relationships. He'd choose business partners who seemed impressive but turned out to be unreliable. He'd hire associates who interviewed well but performed poorly. He'd make investment decisions that seemed logical but consistently underperformed. Michael assumed these failures were just bad luck or insufficient information. Then he learned about cognitive biases and realized that his brain was systematically sabotaging his decision-making in predictable ways. When he implemented AI-inspired bias elimination techniques, everything changed. His investment returns improved by 40%. His hiring success rate went from 70 to 95%, and he avoided several business partnerships that would have been disasters. Here's what most people don't understand about human thinking. Your brain wasn't designed for optimal decision-making in modern environments. It evolved for survival in primitive conditions where quick judgments about immediate threats were more important than accurate analysis of complex information. These evolutionary shortcuts create systematic errors that AI systems are specifically designed to avoid. The CLEAR framework provides systematic approaches to eliminating the most costly cognitive biases. The letter C stands for catch biases in real time through awareness. The letter L means logic check your reasoning processes. The letter E represents evidence gathering from multiple perspectives. The letter A signifies alternative scenarios and devil's advocate thinking. The letter R represents review and calibration of decision accuracy. Let's start with catching biases in real time through awareness. Most people never identify their cognitive biases because these thinking errors feel completely natural and rational in the moment. The first step to eliminating bias is recognizing when you're most susceptible to specific thinking errors. Michael discovered that he was particularly vulnerable to the halo effect when evaluating people. If someone was impressive in one area, he'd automatically assume they were competent in other areas. He'd meet a charismatic entrepreneur and assume they were also financially responsible, operationally excellent, and personally trustworthy. This bias cost him hundreds of thousands of dollars in bad investments and business partnerships. Once he became aware of this pattern, he could catch himself in real time. When he felt impressed by someone's presentation skills or social confidence, he'd automatically remind himself to evaluate their actual track record, financial statements, and references independently. Awareness alone eliminated 60% of his poor people-related decisions. Logic checking your reasoning processes means systematically evaluating whether your conclusions actually follow from your evidence. Most people jump to conclusions based on incomplete information or faulty reasoning, but they never examine the logical structure of their thinking process. Michael implemented what he called reasoning audits. Before making significant decisions, he'd write down his reasoning step by step. What evidence was he using? What assumptions was he making? What logical connections was he drawing? How confident should he be given the available information? This simple practice revealed numerous logical errors that he'd been making unconsciously. For example, he realized he'd been assuming that expensive services were automatically higher quality, even though he had no evidence supporting this connection. He'd been choosing lawyers, consultants, and service providers based on pricing rather than actual performance metrics. When he started logic checking this assumption, he found excellent service providers at lower costs, while avoiding overpriced options that delivered poor results. Evidence gathering from multiple perspectives means actively seeking information that challenges your initial assumptions. This is perhaps the most difficult bias elimination technique, because it requires deliberately looking for evidence that you're wrong, which feels psychologically uncomfortable but dramatically improves decision accuracy. Michael developed systematic processes for gathering contradictory evidence. When evaluating investment opportunities, he'd actively seek out bearish analyses and worst-case scenarios. When considering new hires, he'd look for reasons why candidates might not succeed rather than just focusing on their strengths. When making strategic business decisions, he'd research companies that had failed using similar approaches. This devil's advocate thinking prevented numerous costly mistakes. He avoided investing in several companies that seemed promising initially, but had fundamental problems that he discovered through systematic contrary research. He identified red flags in potential hires that he would have missed if he'd only focused on positive indicators. Alternative scenarios and devil's advocate. Thinking means systematically considering what could go wrong and how your initial assumptions might be incorrect. Most people engage in what psychologists call optimistic planning, where they assume everything will go according to their best-case scenarios. AI systems automatically model multiple scenarios, including negative outcomes. Michael started using pre-mortem analysis for major decisions before committing to investments, partnerships, or strategic initiatives. He'd imagine that the decision had failed completely and work backward to identify what could have gone wrong. This exercise consistently revealed potential problems that he hadn't considered in his initial analysis. Review and calibration of decision accuracy means tracking your decision outcomes and systematically improving your judgment over time. Most people never analyze whether their decisions actually produced the predicted results, so they never learn from their mistakes or improve their decision-making processes. Michael implemented systematic decision tracking. For every significant choice, he recorded his reasoning, his confidence level, and his predicted outcomes. 6 months later, he'd review actual results and analyze where his reasoning had been accurate or flawed. This calibration process dramatically improved his ability to assess uncertainty and make probabilistic judgments. He discovered that he was consistently overconfident in areas where he had limited expertise and underconfident in areas where he actually had strong judgment. He learned to adjust his confidence levels and seek additional input in areas where his track record was poor, while trusting his instincts more in areas where his predictions were consistently accurate. The compound effect of systematic bias elimination is extraordinary. Your decisions become more accurate, your predictions become more reliable, and your ability to identify opportunities and avoid problems improves dramatically. Most importantly, you develop what I call calibrated confidence, where your confidence levels actually match your competence levels. Michael went from feeling like business success was largely luck to feeling like he could predict and influence outcomes through superior thinking processes. His confidence increased because it was based on demonstrated competence rather than wishful thinking. His stress decreased because he was making better decisions with more realistic expectations. Here's your implementation strategy for eliminating costly cognitive biases. Start by identifying which biases affect you most frequently. Do you tend to overestimate your abilities? Seek information that confirms what you already believe. Make decisions based on recent, memorable examples rather than statistical evidence. Assume that expensive options are automatically better. Choose one bias that you recognize in your own thinking and implement systematic safeguards. If you're prone to confirmation bias, create processes for actively seeking contradictory evidence. If you struggle with overconfidence, start tracking your prediction accuracy and calibrating your confidence levels. If you're susceptible to the availability heuristic, develop habits of researching statistical base rates before making judgments. The key is making bias elimination systematic rather than occasional. Build these techniques into your regular decision-making processes rather than just using them when you remember. Over time, better thinking becomes automatic, and you'll start making consistently superior decisions in every area that matters to you. Chapter 7. Systems Thinking Mastery. Here's something that will revolutionize how you approach every challenge in your life. Most people see problems as isolated events and try to fix symptoms rather than addressing root causes. They work harder, spend more money, and invest more time. But their problems keep recurring because they're treating effects rather than understanding the underlying systems that create those effects. AI excels at systems thinking because it can simultaneously analyze complex interdependencies and identify leverage points that create maximum impact with minimum effort. Let me tell you about Lisa, a restaurant owner who was trapped in a cycle of constant crisis management. She was working 80-hour weeks, constantly dealing with staff turnover, customer complaints, inventory problems, cash flow issues, and quality control failures. Every time she solved one problem, two more would appear. She hired consultants, invested in better equipment, and tried countless quick fixes, but nothing created lasting improvement. Then Lisa learned to think in systems like AI, and everything transformed. Within 6 months, her staff turnover dropped by 70%. Customer satisfaction increased dramatically. Profit margins improved by 30%. And she was working normal hours while achieving better results than ever before. The breakthrough wasn't working harder or investing more money. It was understanding and optimizing the underlying systems that drive restaurant success. Here's what most people don't understand about problems. What you see as individual issues are usually symptoms of deeper systemic patterns. When you treat symptoms, problems recur. When you identify and optimize systems, problems solve themselves permanently. AI systems excel at finding these leverage points. Because they can analyze complex relationships and feedback loops that human brains typically miss. The systems framework teaches you to think like AI when analyzing complex situations. The letter S stands for see, the whole, rather than individual parts. The letter Y means map interconnections and dependencies. The letter S represents identify feedback loops and cycles. The letter T signifies find leverage points for maximum impact. The letter E represents evaluate unintended consequences. The letter M means monitor system health continuously. The letter S represents scale solutions systematically. Let's start with seeing the whole rather than individual parts. Most people focus on obvious problems without understanding the broader context that creates those problems. Lisa initially thought she had separate issues with hiring, training, inventory, marketing, and financial management. She didn't realize these were all connected elements of an integrated system. When she started mapping her restaurant as a complete system, she discovered that most of her problems stemmed from unclear processes and inconsistent communication. Staff turnover happened because new employees felt overwhelmed and unsupported. Customer complaints occurred because service standards varied depending on who was working. Inventory problems resulted from lack of coordination between kitchen staff and management. Mapping interconnections and dependencies means understanding how different elements influence each other and identifying the relationships that create systemic patterns. This is where AI thinking really separates itself from typical human analysis. Because AI can simultaneously consider multiple variables and their interactions, Lisa created what she called a restaurant ecosystem map. She identified how hiring practices affected training quality, how training quality influenced service consistency, how service consistency impacted customer satisfaction, how customer satisfaction drove repeat business, how repeat business affected revenue predictability, and how revenue predictability influenced her ability to invest in better systems. This mapping revealed that improving her hiring process would create positive cascading effects throughout the entire system. Better hiring led to employees who learned faster and stayed longer. Longer retention meant more experienced staff providing better service. Better service created more satisfied customers and higher revenues. Identifying feedback loops and cycles means recognizing patterns that either reinforce problems or create positive improvement spirals. Most systemic problems exist because negative feedback loops keep recreating the same issues. Systemic solutions work by creating positive feedback loops that continuously improve outcomes. Lisa discovered several negative feedback loops that were sabotaging her restaurant. High staff turnover led to inexperienced teams, which created poor service quality, which generated customer complaints and stress, which made the work environment less pleasant, which increased staff turnover even more. She was trapped in a downward spiral that got worse over time. By identifying these loops, she could design interventions that reversed the spiral direction. Investing in better hiring and training practices created more competent and confident staff. Better staff provided superior service, which generated positive customer feedback and higher tips. Better working conditions and compensation attracted higher quality employees, creating an upward spiral of continuous improvement. Finding leverage points for maximum impact means identifying where small changes can create disproportionately large improvements across the entire system. This is perhaps the most powerful aspect of systems thinking, because it allows you to achieve major transformations without massive resource investments. Lisa discovered that improving her employee onboarding process was a crucial leverage point. By creating systematic training programs, clear performance standards, supportive mentoring relationships, she could dramatically impact every other aspect of her business. New employees became productive faster. Existing staff felt more confident and engaged. Service quality improved consistently. And customer satisfaction increased measurably. This single systemic improvement eliminated most of her previous problems without requiring major investments in equipment, marketing, or facility upgrades. She was working with the same budget and resources, but achieving dramatically better results by optimizing a key leverage point in her system. Evaluating unintended consequences means considering how changes in one part of a system might create unexpected effects in other areas. AI systems automatically model these secondary and tertiary effects, while humans often focus only on immediate, intended outcomes. When Lisa implemented her improved training system, she anticipated better service quality and reduced turnover. But she also experienced unexpected benefits. Staff members started suggesting operational improvements. Customer complaints decreased so much that she could reduce management oversight. And word-of-mouth marketing increased significantly because employees were genuinely enthusiastic about their workplace. Monitoring system health continuously means tracking key indicators that reveal how well your system is functioning and identifying problems before they become critical. AI systems continuously monitor performance metrics and adjust automatically based on changing conditions. Lisa developed what she called a restaurant dashboard with key metrics that revealed system health, staff retention rates, customer satisfaction scores, average ticket size, repeat customer percentages, food cost ratios, and employee satisfaction measurements. By monitoring these indicators weekly, she could identify trends and make adjustments before small problems became major crises. Scaling solutions systematically means expanding successful approaches across similar contexts, while adapting them to different conditions. Once you've optimized one system successfully, you can apply similar principles to other areas of your life or business. The compound effect of systems thinking is extraordinary. Instead of constantly fighting fires, you're building systems that prevent fires from starting. Instead of working harder to achieve better results, you're working smarter by optimizing the underlying patterns that create results. Instead of temporary improvements, you're creating sustainable transformations that continue improving over time. Lisa went from feeling like she was drowning in chaos to feeling like she was masterfully orchestrating a well-designed system. Her confidence increased because she understood how to create the results she wanted. Her stress decreased because her systems handled routine challenges automatically while preventing most problems from occurring. Here's your implementation strategy for developing systems thinking mastery. Choose one area of your life that feels chaotic, or where you keep experiencing recurring problems. Map the system by identifying all the key elements and how they influence each other. Look for feedback loops that might be creating or perpetuating problems. Identify potential leverage points where small changes could create significant improvements across the entire system. Consider unintended consequences and design safeguards. Implement systematic monitoring so you can track system health and optimize continuously. What you'll discover is that most complex problems have elegant solutions when you understand the underlying systems. Challenges that seemed impossible become manageable when you identify the right leverage points. This is how you develop the systems thinking capabilities that enable sustainable success in any field. Chapter 8: Predictive Thinking Development. Here's something that will change how you make every decision for the rest of your life. Most people react to events after they happen, constantly surprised by outcomes they could have predicted if they had been thinking systematically. They make plans based on optimistic assumptions, get blindsided by predictable problems, and miss opportunities that were clearly visible to anyone analyzing trends and patterns. Meanwhile, AI systems excel at predictive thinking because they can process vast amounts of data to identify probable future scenarios and prepare optimal responses for each possibility. Let me tell you about David, a financial advisor who is excellent at analyzing current market conditions, but terrible at predicting future changes. Despite his expertise and hard work, the portfolios of his clients consistently underperformed because he was always reacting to market shifts instead of anticipating them. He would recommend technology stocks just before tech crashes, suggest real estate investments right before housing corrections, and move money into bonds just before interest rate changes made them less attractive. David thought market prediction was impossible and that successful investing was mostly luck. Then he learned to develop predictive thinking capabilities like AI systems, and everything changed. Within 18 months, his prediction accuracy improved dramatically, The returns of his clients consistently beat market averages, and he became known as one of the most insightful advisors in his firm. Here's what most people don't understand about prediction. The future isn't random or unknowable. Most outcomes follow predictable patterns based on current trends, historical cycles, leading indicators, and systemic forces. AI systems excel at prediction because they analyze multiple data streams simultaneously and identify convergent patterns that indicate probable future scenarios. The Predict framework teaches you to develop AI-level forecasting capabilities. The letter P stands for pattern recognition across time periods. The letter R means research leading indicators and early signals. The letter E represents evaluate multiple scenarios and probabilities. The letter D signifies develop contingency plans for different outcomes. The letter I represents integrate diverse information sources. The letter C means calibrate predictions against actual results. The letter T represents track emerging trends continuously. Let's start with pattern recognition across time periods. Most people focus only on recent events and miss longer-term cycles that create predictable patterns. David started analyzing market history across multiple time frames, monthly, yearly, and decade-long cycles. He discovered patterns that repeated consistently despite appearing random in shorter time periods. He noticed that certain economic indicators preceded market corrections by 6 to 12 months. Political election cycles created predictable volatility patterns. Seasonal trends influenced different sectors in reliable ways. Interest rate changes had delayed but measurable effects on various asset classes. By analyzing these patterns systematically, he could identify high-probability scenarios for future market behavior. Researching leading indicators and early signals means identifying factors that predict future outcomes before they become obvious to everyone else. This is where predictive thinking becomes incredibly powerful for creating competitive advantages and avoiding problems. David discovered that certain economic indicators were more predictive than others. Employment data, consumer confidence surveys, and corporate earnings trends provided better signals than stock market prices themselves. Housing market activity predicted broader economic changes. International trade patterns influenced domestic investment flows. Currency fluctuations affected various sectors differently but predictably. By monitoring these leading indicators systematically, he could identify probable market scenarios months before they became apparent to most investors. This advance warning allowed him to position the portfolios of his clients optimally for changing conditions rather than reacting after changes had already occurred. Evaluating multiple scenarios and probabilities means developing systematic approaches to uncertainty rather than just hoping for the best outcomes. AI systems automatically model multiple possibilities and assign probability estimates to different scenarios. Most humans focus on single expected outcomes and get surprised when reality differs from their assumptions. David started creating scenario matrices for major investment decisions. Instead of predicting single outcomes, he would identify 3 to 5 probable scenarios with estimated probability ranges. He would analyze how different asset classes would perform under each scenario and create portfolio allocations that would succeed across multiple possibilities. For example, when evaluating technology investments, he would consider scenarios including continued growth, regulatory restrictions, market saturation, and disruption by newer technologies. By planning for multiple outcomes, the portfolios of his clients remained resilient regardless of which scenario actually occurred. Developing contingency plans for different outcomes means preparing specific responses for various scenarios rather than hoping you will figure out what to do when things happen. This systematic preparation is what separates people who thrive during uncertainty from those who struggle when conditions change. David created systematic response protocols for different market conditions. If early indicators suggested economic contraction, he had predetermined strategies for defensive positioning. If trends indicated sector rotation, he had plans for reallocating investments. International events created currency volatility. He had hedging strategies ready for implementation. Integrating diverse information sources means gathering data from multiple perspectives rather than relying on single sources or conventional wisdom. AI systems process vast amounts of information from different domains to identify convergent patterns and emerging trends. David expanded his information sources beyond traditional financial analysis. He monitored technology development patterns, demographic trend research, regulatory policy discussions, international economic indicators, and consumer behavior studies. This broader perspective revealed connections and patterns that purely financial analysis missed. Calibrating predictions against actual results means systematically tracking your forecasting accuracy and improving your predictive models over time. Most people never analyze whether their predictions were correct, so they never learn from their mistakes or improve their forecasting capabilities. David implemented rigorous prediction tracking. For every forecast he made, he recorded his reasoning, confidence level, and predicted outcomes. 6 months later, he would analyze actual results and identify where his analysis had been accurate or flawed. This calibration process dramatically improved his ability to assess uncertainty and make probabilistic judgments. He discovered patterns in his own forecasting errors. He was consistently overconfident about technology disruptions and underestimated regulatory impacts. He was better at predicting sector trends than individual company performance. These insights allowed him to adjust his approach and focus on predictions where his track record was strongest. Tracking emerging trends continuously means maintaining systematic awareness of developing patterns that might influence future outcomes. AI systems continuously update their models based on new information rather than relying on static analysis. David developed a trend monitoring system. He tracked emerging technologies, changing demographics, evolving consumer preferences, policy developments, and global economic shifts that might affect investment markets. Instead of waiting for trends to become obvious, he was identifying them early and positioning for their eventual impact. The compound effect of systematic predictive thinking is extraordinary. You make better decisions because you are considering future implications rather than just current conditions. You identify opportunities earlier because you are monitoring trends and patterns that others miss. You avoid problems because you are preparing for multiple scenarios. David went from feeling like markets were unpredictable to understanding that they follow identifiable patterns. The portfolios of his clients benefited from strategic positioning based on systematic analysis rather than reactive decisions. His reputation improved because his recommendations consistently anticipated market developments. Here's your implementation strategy for developing predictive thinking capabilities. Choose one area of your life where you would benefit from better prediction: career planning, investment decisions, business strategy, or personal goal achievement. Start monitoring relevant leading indicators and tracking patterns over time. Develop systematic approaches to scenario planning rather than assuming single outcomes. Create contingency plans for different possibilities. Integrate diverse information sources to identify trends early. Track your prediction accuracy and continuously improve your forecasting methods. Remember, the goal isn't perfect prediction, but better preparation. When you can identify probable scenarios and prepare appropriate responses, you are positioned to succeed regardless of which specific outcomes occur. This is how you develop the strategic thinking capabilities that separate high performers from those constantly surprised by predictable changes. Chapter 9. AI-inspired problem solving. Here's something that will transform how you approach every challenge for the rest of your life. Most people attack problems with random trial and error, hoping that persistence and hard work will eventually lead to solutions. They get stuck in ineffective approaches, waste enormous amounts of time and energy, and often give up just before breakthrough solutions become apparent. Meanwhile, AI systems solve complex problems by breaking them into manageable components, processing them systematically, and optimizing solutions through iterative improvement. The difference in results is absolutely extraordinary. Let me tell you about Rachel, a product manager at a growing startup who was facing what seemed like an impossible challenge. Her team needed to develop a new software feature that would satisfy demanding customers, work within technical constraints, meet tight deadlines, and stay within budget limitations. Traditional brainstorming sessions produced either ideas that were technically impossible or solutions that customers wouldn't actually use. The team was stuck, morale was dropping, and the deadline was approaching rapidly. Then Rachel learned to solve problems like AI systems, and everything changed. Within 3 weeks, her team had identified an elegant solution that exceeded customer expectations, required minimal technical resources, and was delivered ahead of schedule. The breakthrough wasn't working longer hours or hiring more people. It was applying systematic problem-solving methodologies that broke down the complexity into manageable elements. Here's what most people don't understand about complex problem-solving. Difficult challenges feel overwhelming because human brains try to process all variables simultaneously. We get paralyzed by the number of constraints, possibilities, and interdependencies involved. AI systems excel at complex problem-solving because they decompose challenges into smaller components, optimize each element systematically, and then integrate solutions into comprehensive approaches. The SOLVE framework teaches you to approach problems like AI systems. The letter S stands for systematically decompose complex challenges. The letter O means optimize each component individually. The letter L represents look for elegant integrations. The letter V signifies validate solutions through testing. The letter E represents evolve approaches based on feedback. Let's start with systematically decomposing complex challenges. Most people get overwhelmed by problems because they try to solve everything at once rather than breaking challenges into manageable pieces. Rachel's breakthrough began when she stopped trying to find single solutions that addressed all requirements simultaneously. She decomposed her challenge into distinct elements: customer requirements analysis, technical feasibility assessment, resource allocation optimization, timeline management, and stakeholder communication. Instead of searching for magical solutions that would satisfy all constraints perfectly, she focused on understanding each element thoroughly before attempting integration. By analyzing each element separately, you can identify specific leverage points for improvement rather than making Chapter 9 AI-inspired problem solving. Here's something that will transform how you approach every challenge for the rest of your life. Most people attack problems with random trial and error, hoping that persistence and hard work will eventually lead to solutions. They get stuck in ineffective approaches, waste enormous amounts of time and energy, and often give up just before breakthrough solutions become apparent. Meanwhile, AI systems solve complex problems by breaking them into manageable components, processing them systematically, and optimizing solutions through iterative improvement. The difference in results is absolutely extraordinary. Let me tell you about Rachel, a product manager at a growing startup who was facing what seemed like an impossible challenge. Her team needed to develop a new software feature that would satisfy demanding customers, work within technical constraints, meet tight deadlines, and stay within budget limitations. Traditional brainstorming sessions produced either ideas that were technically impossible or solutions that customers wouldn't actually use. The team was stuck, morale was dropping, and the deadline was approaching rapidly. Then Rachel learned to solve problems like AI systems, and everything changed. Within 3 weeks, her team had identified an elegant solution that exceeded customer expectations, required minimal technical resources, and was delivered ahead of schedule. The breakthrough wasn't working longer hours or hiring more people. It was applying systematic problem-solving methodologies that broke down the complexity into manageable elements. Here's what most people don't understand about complex problem solving. Difficult challenges feel overwhelming because human brains try to process all variables simultaneously. We get paralyzed by the number of constraints, possibilities, and interdependencies involved. AI systems excel at complex problem solving because they decompose challenges into smaller components. Optimize each element systematically, and then integrate solutions into comprehensive approaches. The SOLVE framework teaches you to approach problems like AI systems. The letter S stands for systematically decompose complex challenges. The letter O means optimize each component individually. The letter L represents look for elegant integrations. The letter V signifies validate solutions through testing. The letter E represents evolve approaches based on feedback. Let's start with systematically decomposing complex challenges. Most people get overwhelmed by problems because they try to solve everything at once rather than breaking challenges into manageable pieces. Rachel's breakthrough began when she stopped trying to find single solutions that addressed all requirements simultaneously. She decomposed her challenge into distinct elements: customer requirements analysis, technical feasibility assessment, resource allocation optimization, timeline management, and stakeholder communication. Instead of searching for magical solutions that would satisfy all constraints perfectly, she focused on understanding each element thoroughly before attempting integration. By analyzing each element separately, you can identify specific leverage points for improvement rather than making vague commitments to solve everything better. Maybe your budget is tight, but your timeline is flexible. Maybe your technical constraints are real, but customer requirements are more flexible than initially assumed. Maybe your resource limitations can be overcome through strategic partnerships with other teams. Optimizing each component individually means finding the best possible approach for each element before worrying about how everything fits together. This systematic optimization is what allows AI systems to achieve superior performance in complex environments. The team of Rachel analyzed customer requirements through systematic user research rather than making assumptions about what people wanted. They evaluated technical constraints by consulting with engineering teams and identifying exactly what was possible within current architecture. They optimized resource allocation by analyzing team member strengths and availability. They managed timeline pressures by identifying critical path dependencies and potential bottlenecks. This component-by-component optimization revealed opportunities that weren't apparent when trying to solve everything simultaneously. They discovered that customer needs were more flexible than initially assumed. Technical constraints could be addressed through creative workarounds that didn't require major infrastructure changes. Resource limitations could be overcome through strategic partnerships with other teams. Looking for elegant integrations means finding ways to combine optimized components that create synergistic solutions. This is where AI-inspired problem-solving becomes truly powerful. Because the integrated solution often performs better than the sum of its individual parts. Rachel discovered that their optimized components could be integrated in ways that actually simplified the overall solution. Customer requirements could be met through features that leveraged existing technical capabilities. Resource constraints became advantages because they forced creative approaches that were more user-friendly than complex alternatives. Timeline pressures motivated efficient communication that improved stakeholder satisfaction. The integrated solution was more elegant than anything they could have developed through traditional brainstorming. It's because it was built from systematically optimized components rather than random creative ideas. Validating solutions through testing means verifying that your integrated approach actually works before full implementation. AI systems continuously test and refine their solutions rather than assuming theoretical approaches will work in practice. The team of Rachel implemented systematic validation processes. They created prototypes to test technical feasibility. They conducted user interviews to validate customer acceptance. They ran pilot implementations to identify operational challenges. They analyzed resource utilization to confirm budget projections. This systematic validation revealed refinements that improved the final solution significantly. User feedback suggested interface modifications that made the feature more intuitive. Technical testing identified optimization opportunities that improved performance. Operational analysis revealed support requirements that needed to be addressed before launch. Evolving approaches based on feedback means treating solutions as starting points for continuous improvement rather than final answers. AI systems never stop optimizing their approaches based on new data and changing conditions. Rachel implemented systematic feedback collection and analysis processes. User behavior data revealed usage patterns that suggested additional optimization opportunities. Performance metrics identified areas where the solution could be enhanced. Stakeholder feedback provided insights for future development priorities. This evolutionary approach meant that their solution continued improving after launch rather than becoming static. They developed capabilities for rapid iteration and improvement that gave them competitive advantages in responding to changing market conditions. Here's where AI-inspired problem-solving becomes exponentially powerful. Once you develop systematic approaches to decomposition, optimization, integration, validation, and evolution, you can apply these methodologies to any complex challenge. Business strategy, relationship problems, health optimization, career development, and personal productivity all become much more manageable when you approach them systematically. Most importantly, you develop what I call solution confidence. Instead of feeling overwhelmed by complexity, you feel capable because you have systematic approaches for breaking down challenges and building optimal solutions. Instead of relying on inspiration or luck, you can engineer solutions through methodical analysis and optimization. The psychological transformation is remarkable. Instead of avoiding difficult problems, you start seeking them out because you know how to solve them systematically. Instead of feeling frustrated when initial approaches don't work, you view iterations as natural parts of the optimization process. Instead of being intimidated by constraints, you see them as design parameters that guide creative solutions. Rachel went from feeling paralyzed by impossible challenges to feeling energized by complex problems. Her team developed confidence in their ability to find solutions to any challenge because they had systematic approaches that consistently produced results. Their reputation improved because stakeholders knew they could deliver creative solutions to difficult requirements. Here's your implementation strategy for developing AI-inspired problem-solving capabilities. Choose one complex challenge you're currently facing in any area of your life. Apply the solve framework systematically. Decompose the challenge into manageable components. Optimize each element individually. Look for elegant ways to integrate solutions. Validate your approach through testing and prepare for evolutionary improvement. Start with something challenging but not overwhelming. Master the systematic approach with one problem, then gradually apply these methodologies to increasingly complex challenges. What you'll discover is that most problems that seem impossible are actually complex puzzles that can be solved through systematic decomposition and optimization. Remember, AI systems achieve superior problem-solving performance not through creative inspiration, but through systematic analysis and methodical optimization. When you implement these same approaches, you gain the same advantages: consistent solutions to complex challenges, confidence in your ability to handle difficult situations, and competitive advantages through superior problem-solving capabilities. Chapter 10: Human-AI Collaboration Psychology. Here's something that will determine your success in the next decade. The future doesn't belong to humans who compete against AI, nor to AI systems that replace humans entirely. The future belongs to individuals who can collaborate seamlessly with artificial intelligence, combining human creativity and emotional intelligence with the systematic processing, and optimization capabilities of AI. This hybrid approach produces results that neither humans nor AI can achieve independently, and mastering this collaboration will become the most valuable skill of the modern era. Let me tell you about Marcus, a marketing director who initially viewed AI tools as threats to his job security. He resisted using automated systems, believing that human creativity and intuition were irreplaceable in marketing. Meanwhile, his competitors were leveraging AI for data analysis, content optimization, customer segmentation, and performance tracking. The campaigns of Marcus were falling behind because he was trying to compete with human-only approaches against teams using human-AI collaboration. Then Marcus learned the psychology of effective human-AI collaboration, and everything transformed. Within 6 months, his campaign performance improved by 60%. His creative output increased dramatically, and his strategic insights became more accurate and actionable. He wasn't replacing his human capabilities with AI. He was amplifying them through intelligent collaboration that leveraged the strengths of both systems. Here's what most people don't understand about human-AI collaboration. It's not about humans doing some tasks while AI does others. It's about seamless integration, where human and artificial intelligence enhance each other throughout every process. AI handles systematic analysis, pattern recognition, and optimization, while humans provide creativity, emotional understanding, strategic thinking, and ethical judgment. The combination creates capabilities that neither system can achieve alone. The Amplify framework teaches you to collaborate effectively with AI systems. The letter A stands for Assess AI Capabilities and Limitations Accurately. The letter M means Match human strengths with AI processing power. The letter P represents Prepare data and context for optimal AI performance. The letter L signifies Learn from AI insights while maintaining human judgment. The letter I represents Integrate AI outputs with human creativity and wisdom. The letter F means fine-tune collaboration processes continuously. The letter Y represents Yield maximum results through synergistic combination. Let's start with assessing AI capabilities and limitations accurately. Most people either overestimate what AI can do or underestimate its potential contributions. Effective collaboration requires realistic understanding of where AI excels and where human capabilities remain superior. Marcus discovered that AI was exceptional at analyzing vast amounts of customer data, identifying patterns in campaign performance, optimizing ad targeting, and testing multiple variations simultaneously. But AI couldn't understand cultural nuances, develop emotionally resonant messaging, make ethical judgments about marketing approaches, or create truly innovative strategies that required intuitive leaps. This assessment allowed him to delegate appropriate tasks to AI, while focusing his human energy on activities where he provided unique value. Instead of spending hours manually analyzing campaign data, he could focus on developing creative concepts and strategic insights that AI couldn't generate independently. Matching human strengths with AI processing power means designing collaborative workflows that leverage the best capabilities of both systems. This is where human-AI collaboration becomes truly powerful, because the combined output exceeds what either system could produce alone. Marcus developed what he called hybrid campaign development processes. AI would analyze customer data to identify behavioral patterns, preferences, and optimal timing for different segments. Marcus would use these insights to develop creative concepts that resonated emotionally while being strategically targeted. AI would then optimize messaging variations, test different approaches, and provide real-time performance feedback that informed creative iterations. This collaboration allowed him to be more creative because he had better data about what actually worked with different audiences. Simultaneously, his campaigns were more effective because creative concepts were informed by systematic analysis rather than just intuitive guesses about customer preferences. Preparing data and context for optimal AI. Performance means understanding how to structure information and frame questions so AI systems can provide maximum value. Most people get mediocre results from AI because they don't know how to communicate effectively with these systems. Marcus learned that AI performance depended heavily on the quality of input data and the specificity of instructions. Vague requests produced generic outputs, while detailed context and specific objectives generated highly valuable insights. He developed systematic approaches to data preparation and prompt engineering that dramatically improved AI output quality. Learning from AI insights while maintaining human judgment means extracting valuable information from AI analysis without abandoning critical thinking and creative intuition. AI can identify patterns and correlations, but humans must interpret significance and make strategic decisions based on broader context. Marcus discovered that AI often identified patterns he would never have noticed independently. Customer segments that seemed similar actually responded to completely different messaging approaches. Campaign timing that seemed optimal based on traditional assumptions actually underperformed compared to AI-identified alternatives. Product features that he thought were most important weren't the ones that actually drove purchase decisions. But he also learned to question AI recommendations and apply human judgment about whether insights made sense in broader strategic contexts. Sometimes, AI identified statistically significant patterns that weren't practically meaningful. Sometimes correlations didn't imply causation in ways that required human understanding to interpret correctly. Integrating AI outputs with human creativity and wisdom means using AI insights as inspiration and foundation for human creative work, rather than accepting AI outputs as final solutions. This integration is where the most powerful results emerge from human-AI collaboration. Marcus would use AI-generated customer insights to inspire creative concepts that he would never have developed without that data foundation. AI-identified optimization opportunities became starting points for creative experiments that combined systematic analysis with human innovation. Performance feedback from AI-optimized campaigns informed strategic decisions about future creative directions. Fine-tuning collaboration processes continuously means optimizing how you work with AI systems based on results and changing capabilities. AI technology evolves rapidly, so effective collaboration requires ongoing adaptation and improvement. Marcus implemented systematic review processes to evaluate collaboration effectiveness. Which AI tools provided the most valuable insights? Collaborative workflows produced the best results. Which types of tasks were better handled by AI versus human analysis? Which combinations of human creativity and AI optimization generated the most successful campaigns? This continuous optimization allowed him to stay current with AI developments while refining collaboration approaches that maximized results. He wasn't just using AI tools, he was developing increasingly sophisticated capabilities to work with AI systems effectively. Yielding maximum results through synergistic combination means achieving outcomes that neither human intelligence nor artificial intelligence could produce independently. This is the ultimate goal of human-AI collaboration, creating capabilities that transcend the limitations of both systems. The hybrid approach of Marcus produced campaigns that were simultaneously more creative and more effective than anything he could have developed using purely human or purely AI approaches. His creative concepts were more innovative because they were informed by insights from systematic data analysis. His campaign optimization was more effective because it combined AI, processing power with human strategic thinking and creative intuition. The compound effect of effective human-AI collaboration is extraordinary. You become more creative because you have better information about what actually works. You become more effective because your human insights are amplified by AI capabilities. You become more valuable professionally. Because you can achieve results that people using single-system approaches cannot match. Most importantly, you develop what I call collaborative intelligence. Instead of feeling threatened by AI capabilities, you feel empowered because you know how to leverage them effectively. Instead of competing against AI, you're collaborating with AI to achieve superior results. Instead of being replaced by technology, you're becoming irreplaceable through your ability to work with technology effectively. Marcus went from viewing AI as a threat to seeing it as the most powerful tool for amplifying his human capabilities. His creative work improved because he had systematic insights about audience preferences. His strategic thinking became more accurate because it was informed by comprehensive data analysis. His professional value increased because he could deliver results that purely human approaches couldn't achieve. Here's what separates people who thrive in the AI era from those who struggle with technological change. Successful individuals develop collaborative relationships with AI systems rather than competitive or avoidance relationships. They learn to leverage AI strengths while maintaining and developing their uniquely human capabilities. Here's your implementation strategy for developing effective human-AI collaboration capabilities. Choose one area of your work or personal life where AI tools are available and could potentially enhance your results. Apply the Amplify framework systematically. Assess what AI can and cannot do in that domain. Identify how to match your human strengths with AI capabilities, and design collaborative workflows that leverage both systems effectively. Start with simple collaboration and gradually develop more sophisticated integration approaches. Experiment with different AI tools and collaborative methods. Track results to identify which combinations of human and artificial intelligence produce the best outcomes in your specific situations. The future belongs to individuals who can collaborate effectively with AI systems. Master this collaboration now, and you'll have competitive advantages that compound over time as AI capabilities continue evolving. Chapter 11: Future-Proof Cognitive Skills. Here's something that will determine your relevance and success for decades to come. Technology will continue evolving at exponential rates. Industries will be disrupted repeatedly, and job requirements will change faster than most people can adapt. Meanwhile, certain cognitive capabilities will become more valuable over time because they can't be automated, and they actually become more important as AI handles routine tasks. Developing these future-proof skills now isn't just career insurance. It's the foundation for thriving in any future scenario. Let me tell you about Alina, a data analyst who was terrified about job security as AI systems became increasingly capable of automated analysis. She watched as routine reporting tasks were taken over by algorithms. Basic data processing became automated, and even some complex analysis was being handled by AI tools. Alina thought her analytical skills were becoming obsolete and that she needed to completely change careers to remain relevant. Then Alina learned to develop future-proof cognitive skills, and everything changed. Instead of becoming less valuable, she became more valuable than ever. Her role evolved from routine analysis to strategic insight generation, complex problem-solving, and human-AI collaboration leadership. Within 2 years, she was promoted to head of strategic analytics and was earning significantly more while working on more interesting and impactful projects than ever before. Here's what most people don't understand about technological change. AI doesn't eliminate the need for human intelligence. It elevates the type of human intelligence that's most valuable. As AI handles routine cognitive tasks, premium value shifts to uniquely human capabilities that become more important, not less important, in an AI-augmented world. The Evolve framework teaches you to develop cognitive capabilities that become more valuable over time. The letter E stands for emotional intelligence and interpersonal skills. The letter V means versatile learning and adaptation capabilities. The letter O represents original thinking and creative problem-solving. The letter L signifies leadership and influence in complex environments. The letter V represents values-based decision-making and ethical reasoning. The letter E represents emergent thinking and synthesis across domains. Let's start with emotional intelligence and interpersonal skills. As AI handles more analytical tasks, human success increasingly depends on the ability to understand, motivate, and collaborate with other people. These skills can't be automated because they require empathy, cultural sensitivity, and nuanced communication that AI systems don't possess. Alina discovered that her most valuable contributions weren't technical analysis, but her ability to translate complex data insights into actionable recommendations that different stakeholders could understand and implement. She learned to read executive personalities, adapt her communication style to different audiences, and build consensus around data-driven strategies. This emotional intelligence became exponentially more valuable as her organization relied increasingly on AI-generated analysis. While AI could identify patterns and correlations, Alina could understand how those insights would be received by different personalities, what resistance might emerge during implementation, and how to frame recommendations in ways that motivated action rather than just providing information. Versatile learning and adaptation capabilities mean developing the ability to acquire new skills quickly and apply knowledge across different domains. As change accelerates, the ability to learn and adapt becomes more important than any specific knowledge or skill set. Alina developed what she called rapid skill acquisition methodologies. Instead of trying to become an expert in every new technology, she focused on learning how to learn efficiently. She developed systematic approaches to identifying key principles in new domains, finding the most effective learning resources, and practicing new skills in ways that accelerated competence development. This meta-learning capability allowed her to stay current with technological developments without becoming overwhelmed by the pace of change. She could quickly develop working knowledge of new AI tools, understand emerging analytical methodologies, and adapt to changing business requirements faster than colleagues who tried to master everything in depth. Original thinking and creative problem-solving represent perhaps the most future-proof cognitive capabilities. AI excels at pattern recognition and optimization within existing frameworks. But human creativity remains superior for generating novel approaches, innovative solutions, and breakthrough insights that require intuitive leaps. Alina learned to combine AI-generated analysis with creative thinking techniques that produced insights no algorithm could generate. She used AI to identify patterns and correlations, then applied human creativity to develop strategic implications, innovative applications, and novel approaches that weren't obvious from the data alone. For example, AI analysis might reveal that customer satisfaction correlates with response time, but Alina would creatively explore why this relationship exists, what other factors might influence it, and how the organization could innovate around customer experience rather than just optimizing response speed. Leadership and influence in complex environments become increasingly valuable as organizations rely more heavily on AI systems and human-AI collaboration. Someone needs to provide vision, make strategic decisions, manage change, and inspire teams through uncertainty. These leadership capabilities require uniquely human skills that become more important as technical tasks become automated. Alina developed strategic leadership capabilities that allowed her to guide her organization's AI adoption while ensuring human value was preserved and enhanced. She learned to communicate vision, manage resistance to technological change, and create environments where human creativity and AI capabilities could be integrated effectively. Values-based decision-making and ethical reasoning become crucial as AI systems handle more consequential decisions. Humans must provide moral judgment, ethical oversight, and values-based guidance that ensure AI applications serve human flourishing, rather than just optimizing metrics. Alina learned to evaluate AI recommendations through ethical frameworks, consider broader social implications of analytical insights, and ensure that data-driven strategies aligned with organizational values and societal responsibilities. This ethical reasoning capability became increasingly valuable as her organization relied more heavily on AI-generated recommendations. Emergent thinking and synthesis across domains means developing the ability to identify connections and patterns across different fields, integrate insights from multiple sources, and generate novel understanding that emerges from combining diverse perspectives. Alina developed capabilities to synthesize insights from data analysis, psychology, business strategy, technology trends, and organizational behavior in ways that produced strategic understanding no single domain could provide. This cross-domain thinking allowed her to identify opportunities and solutions that specialists focused on single areas would miss. The compound effect of developing future-proof cognitive skills is extraordinary. Instead of becoming obsolete, you become more valuable as technology advances. Instead of competing against AI, you're developing capabilities that complement and enhance AI performance. Instead of being threatened by change, you're positioned to benefit from technological evolution. Alina went from fearing technological displacement to becoming a leader in AI-augmented analytics. Her combination of technical competence and uniquely human skills made her invaluable in an AI-enhanced environment. Her career trajectory accelerated because she developed capabilities that became more valuable as AI handled routine tasks. Here's what separates people who thrive during technological disruption from those who struggle with change. Successful individuals focus on developing capabilities that complement rather than compete with AI systems. They invest in skills that become more valuable as automation handles routine tasks. The psychological transformation is profound. Instead of feeling anxious about technological change, you feel excited about opportunities to apply uniquely human capabilities in new ways. Instead of trying to compete with AI, you're developing skills that make you irreplaceable in an AI-augmented world. Here's your implementation strategy for developing future-proof cognitive skills. Assess your current capabilities using the Evolve framework. Which areas are already strong and which need development? Create systematic development plans for enhancing emotional intelligence, learning agility, creative thinking, leadership capabilities, ethical reasoning, and cross-domain synthesis. Focus on one area at a time rather than trying to develop everything simultaneously. Practice these skills in your current role while seeking opportunities to apply them in new contexts. Remember, these capabilities develop through practice and application, not just study and reflection. The key insight is that future-proof skills aren't just about career security, they're about human fulfillment. As AI handles routine tasks, humans can focus on work that requires creativity, empathy, wisdom, and moral judgment. These are the activities that create meaning and satisfaction in human experience. Invest in developing these future-proof cognitive capabilities now. Your future self will thank you for building skills that become more valuable over time, rather than competing with capabilities that AI will inevitably surpass. Chapter 12. AI Mindset Integration Protocol. Here's the moment where everything comes together. You've learned how to think systematically like AI, eliminate cognitive biases, recognize patterns, construct logical frameworks, make data-driven decisions, solve problems methodically, collaborate with AI systems, and develop future-proof cognitive skills. But knowing these techniques isn't enough. The transformation happens when you integrate all these capabilities into a cohesive mindset that becomes your default way of thinking and operating in the world. Let me tell you about Thomas, a consulting firm partner who had absorbed all the concepts we've covered but was struggling to implement them consistently. He would use systematic thinking for some decisions, but revert to old patterns under pressure. He would apply bias elimination techniques occasionally, but forget them during stressful situations. He had all the tools, but hadn't developed the integrated mindset that makes AI-inspired thinking automatic and effortless. Then Thomas implemented the AI Mindset Integration Protocol, and everything clicked into place. Within 3 months, his decision quality improved dramatically across all areas of life. His consulting recommendations became more accurate and valuable. His personal relationships improved because he was thinking more clearly about interpersonal dynamics. His financial decisions generated better results because he was applying systematic analysis consistently. Most importantly, these improvements felt natural and sustainable rather than forced or exhausting. Here's what most people don't understand about lasting behavioral change. Learning individual techniques isn't enough to transform how you think and operate. Real transformation requires integrating new capabilities into a unified system that becomes your natural way of processing information and making decisions. This integration is what separates people who occasionally use AI-inspired thinking from those who embody it consistently. The Integrate framework provides a systematic approach to making AI-inspired thinking your default mindset. The letter I stands for Identify Current Thinking Patterns and Limitations. The letter N means Navigate Obstacles to Consistent Implementation. The letter T represents Train New Neural Pathways through Deliberate Practice. The letter E signifies Establish Environmental Triggers and Support Systems. The letter G represents Generate Feedback Loops for Continuous Improvement. The letter R means Reinforce Progress through Systematic Measurement. The letter A represents Automate Optimal Thinking Patterns. The letter T represents Transform Identity and Self-Concept. The letter E represents Evolve Capabilities Continuously over time. Let's start with identifying current thinking patterns and limitations. Most people never analyze how they actually think and make decisions, so they can't recognize when they're reverting to suboptimal patterns. Thomas conducted what he called a thinking audit, tracking his decision-making processes for 2 weeks to identify where he was already, using AI-inspired approaches and where he was falling back on old habits. He discovered fascinating patterns. He used systematic thinking for business decisions, but made impulsive choices about personal purchases. He applied data analysis rigorously for client work, but relied on assumptions for family planning. He was excellent at eliminating bias when evaluating investment opportunities, but completely subjective when assessing people in social situations. This awareness allowed him to identify specific areas where integration was needed most urgently. Instead of trying to change everything simultaneously, he could focus on the thinking patterns that would create maximum impact if improved. Navigating obstacles to consistent implementation means identifying and addressing the barriers that prevent you from using AI-inspired thinking consistently. Most people know what they should do, but struggle with execution because they haven't addressed psychological and practical obstacles. Thomas identified several implementation barriers. Time pressure made him revert to quick, intuitive decisions. Emotional stress reduced his ability to think systematically. Social situations made him prioritize fitting in over optimal decision-making. Fatigue decreased his willingness to apply rigorous analysis. Information overload made him default to simplified heuristics. By identifying these obstacles systematically, he could develop specific strategies for maintaining AI-inspired thinking even under challenging conditions. He created simplified decision frameworks for high-pressure situations. He developed stress management techniques that preserved cognitive clarity. He practiced systematic thinking in low-stakes social contexts until it became natural in more complex situations. Training new neural pathways through deliberate practice means systematically developing AI-inspired thinking until it becomes automatic. Most people practice randomly and inconsistently, which doesn't create lasting behavioral change. Systematic practice with progressive difficulty creates permanent neural pathway development. Thomas designed what he called cognitive training protocols. He started with simple decisions like restaurant choices and applied the full AI-inspired thinking process, gathering data about options, considering multiple criteria, eliminating cognitive biases, and evaluating outcomes systematically. As these processes became automatic for simple decisions, he gradually applied them to more complex challenges. Establishing environmental triggers and support systems means creating conditions that make AI-inspired thinking easier and more likely. Most behavioral change fails because people rely on willpower rather than designing environments that support desired behaviors. Thomas restructured his environment to prompt systematic thinking. He created decision templates for common choice types. He established information-gathering checklists for important decisions. He scheduled regular review sessions to analyze decision outcomes and identify improvement opportunities. He found colleagues who were also interested in systematic thinking and created accountability partnerships. Generating feedback loops for continuous improvement means creating systematic ways to assess whether your integrated AI mindset is producing better results. Without measurement, you can't know whether changes are actually improving your outcomes or just making you feel more systematic. Thomas implemented comprehensive measurement systems. He tracked decision accuracy by comparing predicted outcomes with actual results. He measured problem-solving effectiveness by analyzing how quickly and elegantly he resolved different types of challenges. He assessed relationship quality to determine whether systematic thinking improved his interpersonal interactions. Reinforcing progress through systematic measurement means celebrating improvements and using success momentum to accelerate further development. Most people don't recognize their progress, which reduces motivation for continued improvement. Thomas created what he called progress dashboards that tracked improvement in various thinking capabilities. He measured decision quality, problem-solving speed, pattern recognition, accuracy, bias elimination effectiveness, and collaboration success rates. Seeing measurable improvement in these areas motivated continued practice and refinement. Automating optimal thinking patterns means developing such fluency with AI-inspired approaches that they become unconscious. Competence rather than requiring deliberate effort. This automation is what makes integrated AI mindset sustainable long-term. Thomas noticed that certain thinking patterns had become completely automatic. He naturally gathered data before making significant decisions. He automatically considered multiple scenarios when planning future activities. He reflexively looked for systemic patterns when problems occurred repeatedly. He instinctively applied bias elimination techniques when evaluating people or opportunities. Transforming identity and self-concept means shifting how you think about yourself from someone who occasionally uses systematic thinking to someone who naturally thinks like an integrated human AI system. This identity transformation is crucial for maintaining behavioral change long-term. Thomas began identifying himself as a systematic thinker rather than someone trying to become more systematic. This identity shift influenced all his decisions because he naturally asked what a systematic thinker would do in various situations. His self-concept supported consistent application of AI-inspired thinking rather than requiring constant conscious effort. Evolving capabilities continuously over time means treating AI mindset integration as an ongoing development process rather than a fixed achievement. As AI technology advances and your life circumstances change, your integrated thinking capabilities must also evolve. Thomas implemented systematic capability development planning. He stayed current with developments in AI and cognitive science that might suggest new thinking techniques. He regularly assessed whether his integrated approach was still optimal for current challenges. He experimented with advanced thinking methodologies and integrated successful innovations into his overall system. The compound effect of complete AI mindset integration is extraordinary. You don't just think better occasionally, you think better consistently across all areas of life. Decision-making becomes more accurate, problem-solving becomes more effective, pattern recognition becomes more sophisticated, and collaboration with others becomes more productive. Most importantly, you develop what I call cognitive confidence. You trust your thinking processes because they are based on systematic analysis rather than random intuition. You feel capable of handling complex challenges because you have integrated approaches that consistently produce superior results. You remain calm under pressure because you know how to think clearly, regardless of circumstances. Thomas went from feeling overwhelmed by the complexity of modern life to feeling empowered by his ability to think systematically about any challenge. His professional performance improved because clients trusted his analytical capabilities. His personal relationships improved because he was making better decisions about time allocation, communication, and conflict resolution. Here's your implementation roadmap for complete AI mindset integration. Start by conducting your own thinking audit to identify current patterns and integration opportunities. Choose one area where systematic thinking would create maximum impact and begin practicing AI-inspired approaches consistently in that domain. Create environmental supports that make systematic thinking easier. Establish measurement systems that track your progress. Celebrate improvements to maintain motivation. Practice until optimal thinking patterns become automatic. Gradually expand integration to other areas of your life. The future belongs to individuals who can think like integrated human AI systems. Master this integration now, and you will have cognitive capabilities that compound over time and remain valuable regardless of how technology continues evolving. This is your transformation from random thinking to systematic thinking, from reactive decisions to predictive planning, from individual limitations to hybrid intelligence. Welcome to thinking like artificial intelligence while remaining brilliantly human.